Spinal cord injury is devastating. It's devastating because it happens to perfectly normal people. You could be riding your bike home from school, and get hit by a car and fall over the handlebars and land on your head. You could dive into shallow water, you could fall off a horse, you could be in a rugby tackle, you could be skiing. Perfectly normal people going about perfectly normal things, and in an instant, your life is changed forever. Because the problem is, the spinal cord is the superhighway of communication between the brain and the rest of your body. Everything from your brain to control your body has to go through the spinal cord, and everything from your body up to your brain has to go through the spinal cord. So when you damage it, you've broken that highway. You can think of it as a highway made up of millions of wire cables, electrical cables or fibre optic cables if you want. It's like when you break those cords, you've flicked off the switch to your body. And when that light goes off, it goes off forever. Imagine what it's like. You're riding home after a great day at school, and next thing is you're in hospital and you can't move. Perry Cross was playing rugby, trying out for a Queensland team. He went in, pushed his body to the limit to do that extra tackle so his team would win. But with a millimetre wrong distance to the left or the right, he broke his spinal cord high up. 24 years ago that happened. He can't feel anything below his neck. He can't move anything below his neck. Imagine what it's like to have your hands sitting there. You can see your hands, but no matter how much you want them to move, you can't get them to move. And no matter how much you want to feel your hand or your leg, you can't. Perry can't feel the warm Queensland sun on his skin. He can't go to the beach and feel our fantastic sand between his toes. He wants to. So when he was injured, he was told he had 5 years to live because that was what they could best hope for way back then. But thanks to medicine, people now live a long time. In fact, they live as long as the rest of us who've got full, healthy bodies. But they have to live with paralysis forever. And so Perry said, this is not good enough. It's not good enough. We are smart human beings, we can create a therapy. And so he wanted to make the impossible possible. And people like Professor Adam Sim in the middle here, who was the 2017 Australian of the Year. He joined together with other scientists around the world to find out how we can create a therapy. He was awarded this 2017 Australian of the Year prize because of his work way back in 2002 here in Queensland, when he tested the transplantation of cells from the nose into the spinal cord. His work showed that it was safe for use in humans. And because of his work, scientists around the world have continued to work on this therapy. But the nose? Why the nose? When we breathe in, we don't just breathe in air. We breathe in bacteria and viruses and toxic chemicals. And the nerve cells that detect odours are killed by those. 1 to 3% of the nerve cells that detect odours die every single day. But they're replaced by stem cells. Those stem cells give rise to new nerve cells. Those nerve cells grow up into the brain and make new connections every single day. And so scientists says, well, if we can understand what makes that so special, we could take that information and transplant it to other parts of the nervous system to help it regenerate. And that's what happened. In 2014, scientists from the University College London teamed up with some Polish scientists and neurosurgeons and they tested this in human. This guy here had been stabbed in the back with a knife. He had a 7mm gap in his spinal cord. They put in a nerve bridge and transplanted olfactory cells with it. And after intensive rehabilitation, he was able to not only move again, but also to feel. This is the first time in history that a man had regeneration of the spinal cord thanks to this therapy. And at the time, Professor Jeffrey Reisman from University College London, who led the study, he said it was a greater achievement than man landing on the moon. And I agree with that, because the spinal cord is so complex, there are so many unknowns that we still don't know how to do it properly. Travelling to the moon took a mammoth effort. When the Americans wanted to go, they put massive amounts of money into it and big teams into it, and it took them 10 years. So we need this approach to do the same thing for spinal cord injury. This is where modern science comes into it. Science is changing, and changing very fast. Innovation is not creating an idea. Innovation is that whole pipeline from the consumer way back into the lab. We have to start with what the patient wants. And what the patient wants is to have their bodies back. They want to be able to feel, and they want to be able to move again. And to do that, we need a cell therapy. But then we have to talk to the clinicians. There's no point creating something that doctors can't use. So we have to make sure that whatever we use can suit the medical professionals. And then it's got to cost right. It's got to be priced at the right point so that someone will pay for it. It's going to be governments, it's going to be insurance agencies, or it might be even out of your own pocket. And most people who live with spinal cord injury don't have great incomes because they can't really work. And so we have to price it at the lowest level possible to make it accessible to everyone who needs it. There's 15,000 people in Australia living with spinal cord injury. But our near neighbours in Indonesia have 15,000 people a year getting spinal cord injury. And then once we know what the product should look like and we know how much it should cost, then we can design it. So that's the way science works these days. You work from the consumer back into the lab. And so to do that, we need big teams of people. No more do we have a professor with a couple of people, we need big teams. And what we need in those teams are crazy ideas, brilliant ideas and diverse ideas. This is some of my team at Griffith University. Every single person here is different. And you can see, we've got males, we've got females, we've got people from all around the world have come to here to make this therapy work. Most people who win a Nobel Prize are young people with a crazy idea that hasn't been tested before. That's what we need to get this therapy to work. This is a movie of axons growing in a living animal. The nerve cells are looking for their targets, and it's a time-lapse movie, so sped up. They're looking for their targets, they're always trying to find where to go. We have to recreate this in the spinal cord. But the next movie, it's a bit not very bright, is it? But the next movie shows in real time an axon moving. You've got little filopodia sticking out. All around that are other cells we can't see. And what's important is that this is just one nerve cell. In the spinal cord, there are millions of these. We have to guide to their right target. And then we have to use cells in a different way. It's not hard to get cells to do their job. We just have to get them to do the right job in the right environment. And so thanks to a fantastic young scientist in our lab, Mo, he's created a new system for growing cells in 3D. And then we can transplant these into an animal. And we use mice to test it. This is a movie of a mouse, perfectly normal, healthy mouse, running along a ladder. We can then induce the injury, which is pretty dramatic, of course, on the animal. It's paralysed and can't walk. But after we transplant the cells into the animal, it's up and running again. This is unbelievable. 20 years ago when I started, this was not possible. But now we can do it. But it's not good enough yet. It's got to get better. We need better results, we need more consistent results, and we have to make it work in a human. And also the problem is that when those nerve cells grow, they don't get to the right targets. They get lost a bit. Some of the nerve cells will find their way to the target, other ones will go off a little bit to the wrong area. There won't be enough to make the threshold level for signalling to occur. So we need long-term rehabilitation. That costs money. So we have to provide a long-term rehabilitation system that can be afforded by the people and paid for by the government. Without this, the cell transplantation is a waste of time. So the problem gets even bigger and more complex when you think about the whole pipeline from the patient being injured to the time when that person goes back home, fully recovered. There is more than just a cell transplantation therapy involved. We have to look after the whole patient in their journey. We have to have psychology in there as well, so that we can get inside the person's mind. Because to have a cell transplantation that might work, and then have to do long-term rehab where they have to keep on going, hoping there'll be some recovery, and keep them motivated, is pretty tough work for everyone, particularly for the people who receive the cells. So the question is when? When will it happen? With regeneration, once it starts too, things will go wrong, and it'll be like the over-stimulation of some cells. We have to modify that over time and get it just right. That takes a long time. But the question is when? When can we get this therapy into the clinic? Because I can tell you, Perry Cross, I saw the other day, he's sick and tired of being in a wheelchair. And he says to me, he wants us to get the therapy now. We're not ready yet. So when is it going to happen? Well, here we are, 2018, and the clock's ticking. We are under pressure as scientists, but also as a community to make this happen. But how long will it take? We have to test the therapy in the clinic. We have to make sure it's safe. So, say 12 years, is that enough? In 12 years' time, people here who go to school now, you probably would have gone to university maybe. You might have even done a PhD. And so you guys will be the ones who then have the jobs. And you'll be the ones with the crazy ideas, the new ideas that we haven't yet thought of, that might just make the therapy even better. I can tell you, I've got a lot of experience in science, and I'm not good enough because I don't have the answers. If I did have the answers, we'd have a therapy already in the clinic. So it's your generation that have the responsibility. So good luck. But I don't think Perry would be happy to wait another 12 years. That's too long. You're going to have to get even cleverer. We're going to have new ideas. We're going to have to add on robotics and electrical stimulation to make it happen faster. 2020 is our target for a clinical trial. But how can we get it there just that little bit faster? What new ideas? What are we missing? I spend a lot of my time thinking like a cell. I've been transplanted into the spinal cord. What is it that I want? What is it that I need to get to my target? And how can we recreate that? So this is where the fine detail is important. You can look at the big picture, but the fine detail is also important. You need everything. But obviously, it's going to be a community approach. It's not just a bunch of scientists at the university doing it. We have to work with the people who live with spinal cord injury. We need to know what they want. We need to work with the clinicians. We need to work with the politicians. We need to work with the people who give us the money. Philanthropy, funding bodies. And we need to work with different scientists around the community, in Australia, overseas as well. We don't care who creates a therapy. It might be us. It'd be fantastic if it was. But if it's someone else, if we get beaten, that means they've brought that clock down. If the therapy's out in 2019, Perry won't care who gives it to him as long as it happens. So bring on the competition. That puts pressure on everyone. But ultimately, we want a headline. We want a headline like this, which was just before the moon landing, almost 50 years ago. When will they walk? Wouldn't it be fantastic if school children were let home to watch TV when the first person was going to walk again, properly walk again, after having their spinal cord repaired? This is what we're after. As a community, we want this to happen. So, when you see Perry Cross down here on the Gold Coast or anyone else in a wheelchair, think how can you help? It's not just a cell biologist. We want engineers, we want politicians involved. So science is more than that. We want good communicators, people who can write our grant applications. We want people who can write media stories to spread our word. This is modern science. This is progress. And this is what we need to do to achieve great things in the future. Thank you.